Welcome to Mathlink Academy, where we connect the dots. I am Mr. C, and in this unit, we're going to talk about solving systems of equation, looking at the substitution method and also at the addition of elimination. So let's get started. Systems of equations. We want to solve in this unit systems of equations using three different methods, focusing basically on two of the three. One way we want to start off is through the addition and elimination method, or they call it addition by addition or subtraction. Another method is the first way we're going to start off is graphing the sets or graphing those particular linear equations and then seeing where the solution is located at. The last method we're going to use is elimination by substitution. Now let's look at the first way. We want to graph these two equations and find where the points intersect. And if the points do intersect, that's our solution, and then we write the answers of where they intersect at. So let's go to our whiteboard. Using this method of the graphing is not the best way, but at least gives you an idea of where the solution is, if there is a solution. So I'm going to look at three different graphs. So let's say we have a linear equation, and let's call that L1. And it gives us this particular line, and another line, let's call it L2. If you graph those two equations and they intersect, the answer is going to be where they intersect. And then you write out what that answer is X, Y as a coordinate. This is known as a one solution. Or another name is it's consistent. So when you say it's consistent, it means it has one solution. So that's one thing that can happen. The other thing that can happen is you can graph a line, let's call it L1. You can graph another line, let's call it L2. Now, these two lines, they're supposed to look, but are parallel to each other. That's what it's supposed to look. Now, since they're parallel, they never cross. And therefore, if there are two lines you graph and they never cross, then our answer would be no solution. There is no solution. And that's the answer you can use. And we're going to circle it. If there's no solution, we also can name it non-consistent or not consistent. Now there's a third thing that can happen. Let's look at the third thing that can happen with a system of equations. You can graph a line, let's say this is L1, and then let's say you graph the other line, L2. I'm using a different color here. And it looks like L1 and L2 are the same line, which they are. If that happens, then you have the answer being infinite many solutions. And we use infinity here. And we call that dependent. So there are basically three things that can happen. You can have one solution, no solution, or infinite many solutions. And then we have the name consistent or not consistent or dependent. Now, let me show you how this can happen when you graph using this method of graphing. Again, this is a cruel method and it gives you an idea. And the next two methods are the methods that we really want to focus on, elimination and also substitution. But let's stick with, at this time, with the graphing and show how it's set up with the system of equation. So to write a system of equation, that's a curly bracket, you have an equation. Let's say we have 3x plus 2y is equal to 6. So that's an equation, and you can graph that. You can plot points and graph that equation. Let's say you have another equation, x plus y is equal to 7. And so when they say solve a system of equation, in this particular unit, we want two equations. Here's two equations. And also we have two unknowns, our x and our y. And what you want to do basically is graph each of these separately. And so for the top equation, we'll call that L1. And then for the bottom, we'll call that L2. And what can happen with this particular system of solution, L1 and L2, you have either one of these three things that will happen. Only one thing will happen within these three. All three things won't happen. Either they will intersect, they will be parallel, or they will be the same line. So given this system of equation, you decide which one is L1 and L2, then you can use your method of graphing that you learned and that we have in other resources in the Mathlink website to know how to graph using the Cartesian coordinate system or the rectangle coordinate system of these particular equations. So the first method we want to use algebraically is called the elimination method, or some will call it addition method, or even the subtraction method. I tend to focus on addition. So the most convenient way of certain equation systems or systems of equations is to add those equations together to get your solution. And so what I like to do is show you an example of how the addition method or the elimination method is used. So let's look at this example. It says solve the following systems of equation by using the addition method, or we could say elimination method. In this particular problem or example, we have our system 5x plus 2y equals 19, 3x minus 2y equals 5. And to use this method, we basically add. That's why I like to say add. And what you want to do when you use the addition method, you want to get rid of one of the variables. Sometimes you can decide which one, or sometimes you may see which one may be easier to get rid of. And so when I add these two equations and make sure that your x and your y's and your numbers are all lined up. So if your x is not lined up, rearrange your equation so the x's are lined up, the y's are lined up, and the number is lined up. In this example, our x's are lined up, our y is lined up, and our numbers are lined up. And so to use the addition method or the elimination method, we're just going to add. So here's our system. We're going to add, and this gives me 8x, so all the x's. The positive 2y and the negative 2y actually would give me 0, so there's nothing there. And this will equal to, adding going down, 24. So now you have eliminated, that's what we call the elimination method. You eliminated one of the variables. We could have eliminated the y if we wanted to, or as this case, we're looking at solving for x. Now let's solve for x. Divide both sides by 8, and therefore x is equal to 3. Now we're not done, because we want to figure out also, is there a y value? We have an x value. We want to also figure out if there's a y value. So what we're going to do, we're going to use this value, x equals 3, and plug it into any one of these equations. It doesn't matter. In this case, I'm going to plug it into the top one. And so I'm going to say 5 times 3, that's my x value, plus 2y is equal to 19. Now we're going to solve for y. So this will be 15 plus 2y is equal to 19. Therefore, 2y, as we subtract both sides by 15, in this case, gives us 4. And therefore, divide both sides by 2. And that's what we have here. Now, if you want to write this answer as an ordered pair, it's xy. And so we have 3, 2. That is our answer in this particular case. 3, 2, or you can say x is equal to 3, y is equal to 2. So looking on this whiteboard, I rewrote the same equation. And what I'm going to do is use the graph approach. Again, the graph approach just gives us an idea of the solution. It may not be the best way of getting the exact solution, but at least gives us an idea. So let me call this L1 and L2. And so for L1, if I graphed it, I may end up something with a line like this. Here's L1. And so if you graph it, you can graph it many different ways. You can solve for y and set it as y equals mx plus b and graph it that way. Or you can pick 2 points for x and y and graph those 2 points. Same thing for L2. L2, we'll graph that and give you at least an idea how it looks. And so looking at this particular one, if I pick 2 points for x and y, x is 0, that's solve for y. When y is 0, solve for x. We get a particular line that will look somewhat like this here. And so this would be L2. Now, where they intersect at will be our answer. And so for this one, it intersects right here. And so we need to see, where's that point? What is that point? So if you look at this graph, it looks like it's about, here's 3 and 2. And so my answer would be 3, 2. And in this case, this is my answer. And it looks like the very first one I did earlier as an example with graphing. It's one solution, which means it's consistent. So this is an example of one solution that is consistent. Now remember, not all systems of equations will give you one solution, but this one will. Some may be inconsistent with no solution or dependent with infinite. We may look at some of those a little later, but for right now, this is a great example of a one solution. So let's look at another system of equations and solve this using the elimination method or the addition method. Now in this case, I just cannot add the x and the y's, even though they're lined up, which is good. First thing, the x's are lined up, the y's are lined up, and the numbers. Make sure they're lined up on the equations. Now, what we need to do is decide, and it doesn't matter which variable you want to get rid of. Do you want to get rid of the x or the y? In this case, I want to get rid of the y. And so to get rid of the y, I got to make sure that my coefficients are the same and one is the opposite of the other one. So looking at my y's, this is the one I'm going to get rid of, are my y's. I have a 2 here and I have a -6 here. That's really a -6. I need to make them both the same and have one being the negative or the opposite sign of the other. So when I add, it eliminates it. So as I look here, what I can do, I can make this 2 a 6 by multiplying it by 3. So to do that, I got to do the entire top equation by 3. So what I'm going to have to do is multiply the top equation by 3. All the way through. So when I multiply this top equation by 3 all the way through, it gives me another equation. It's the same one, but written differently. And you want to say y by 3, because you'll see in a second. 3 times 8 is 24x. 3 times 2, positive 2, is 6y. And then 3 times a negative 18 is a negative 54. And then I didn't do anything to the bottom equation. Now, let me show you why I multiply the top equation by 3. So you got to multiply the whole equation by 3, because notice here, I have a positive 6 and a negative 6. And when I add it together, that will cancel out my y. Again, my goal is to cancel out the y. Now, if I didn't see that, I also can cancel out the x's if I wanted to. In this case, I have to make sure I multiply a negative number either to the top or the bottom equation to cancel out the x. Now the x's are 8 and 10. And so one thing you're going to multiply is the top equation by 10 and the bottom equation by a negative 8. That gives you 80. And when you add them, that will eliminate the x. But right now, let's just focus on the y's. So now using the elimination method, I'm going to add. When I add, this gives me, I believe, 34x. This cancel out. And this here gives me a negative 70, if I'm not mistaken, 72 in this case. Now, one of the things I want to make a correction on, and I want you to make sure you make a correction on this too, this negative 18, I really want it to be a negative 14. So I'm going to change up a little bit here. So let's make this a negative 14. My original was negative 14. So this is 14. And this actually would give me, if my math is correct, a negative 68. So originally it was a negative 14. Now, my y's are eliminated. I have 34x is equal to a negative 68. And then I'm going to divide by 34 to get x by itself. So x in this case will equal to a negative 2. Now I'm not done because I have an x value, but I got to find my y value. So I'm halfway done. So what do? I plug this negative 2 into x into either of the equation. It doesn't matter which one. In this case, I'm going to plug it into the top one. And then I'm going to solve for y, and that'll give me my y value. So I'm going to write this one in blue so you know I'm substituting. And so I have 8 times a negative 2 plus 2y is equal to a negative 18. So I'll get that negative 18 in a minute. So let me just show we can see what these problem is here. So I'll give you what we have here. So negative 2 times 8 is a negative 16. Plus 2y is equal to a negative 18. That negative 18 will come in sooner or later. And so I'm going to add 16 on both sides. So I have 2y is equal to, in this case, it will be a negative 2. Divide both sides by 2. y is equal to a -1. Now you want to make sure these numbers work to double check. So it looks like we have a one solution or a consistent. And so in this case, we'll plug it in, double check it. So -2, that'd be 16. Yep, -18, that works for the top. -2 and the 10, yeah, -20 plus that is -14. So that's my answer. X equals a -2, y equals a -1. Again, if you want to write it as an ordered pair, you just say -2, 1. And this is a one solution. Again, this is my answer. If we go back to our drawing, this would be a one solution, which is consistent if you graph both of those linear equations. Now I want to look at some side notes. You say, well, Mr. C, we've been getting all the one solutions. How about if you get a no solution or independent or infinite or dependent infinite solution? How does that look, Mr. C? So let me show you. So let's say we have an equation here. Let's call it 2x minus 4y is equal to 6. And let's do another one. Let's say 8x minus 16 is equal to 24. And we're going to use the elimination method. In this case, you have to decide which variable you want to get rid of. In our case, I'm going to get rid of x. We're going to do a little differently. So let's get rid of x. So to get rid of x, I have to make sure both the coefficients are the same and one is the opposite sign. So one thing we can do, I'm going to multiply this top one, now right here, do it in green, by 4, or I'll say -4 because I want to be the opposite sign, and leave the bottom one alone. So let me show you what I got here for -4. I'm going to erase this so you can see. So this top one by -4, not a positive, but a negative. So what happens here, this equation on the top will look like this. A -8x plus 16y is equal to a -24. And for some reason, we're going to get that negative value in there, -24. The bottom equation stays the same. 8x minus 16y is equal to a +24. So when we use the elimination method, when we add, your x's cancel. Notice this, the x's cancel. But notice, look, the y's cancel, and also the numbers cancel. So we end up with 0 is equal to 0. So what happened was the equations, they basically were the same. They eliminate each other. We were not able to get x equal to a number or y equal to a number. So whenever you get 0 equals 0, or maybe 10 equals 10, which is true, 3 equals 3, and basically this 0 equals 0 saying that's true, that is true. When you get this happen, this means you have infinite many solutions. So this is an example of something with infinite many solutions. And it happens when you eliminate the x and y's in the numbers and you get 0 equal to 0, because that is true. And so when you have something like this, this gives you a graph of infinite many solutions, which we also can say is dependent. So it will look like this bottom one. It's the same graph. Let's look at one more. So let's write this one down. Let's say you have 2x plus 3y is equal to 7. And then let's say you have, on this one down here, 3x plus 6y is equal to 5. Okay, let's write that one down. So again, as a system, put a curly brackets. Our x's are lined up, our y's are lined up, our numbers are lined up. Next thing, we have to decide who do we want to get rid of. In this case, I want to get rid of x. In that case, to get rid of x, I got to have these being the same coefficients, but one being a negative, the opposite sign. So when I add, it becomes 0. I'm going to multiply the top by 3 and the bottom by a -2. And you can do this. So I'm showing you another way that you can multiply both equations by different constants. You can do that. Previously, we've only been using one equation, only multiplying by one constant, or you could do both equations by different constants. Now you see why I use 3 and -2. So for the top one, I'm going to do it down here so I'll be able to see it. We end up with 6x plus 9y. And then 3 times that is 21. This bottom one, we end up with a -6x plus, and in this case, what I'm going to do a little differently, I'm going to change this, and I'm going to show you something. If this usually would be 12, but I'm going to show you something. Let's say this was 9y is equal to negative, this would be a -10. I'm changing this a little bit just to show you something. Now let's do the elimination method because I want to show you a different example. And when I add, my x's cancel. And in this case, again, since this was a -2, I want to make this a -9. And let's say, and I know it's not, I know -2 times 6 is not -9, but let's say we had -9 here. This will cancel. So we get 0 on this side equal to, and let's add this, 21 plus 10. This gives us a negative, or excuse me, a positive 11, excuse me. Now in this case, it says 0 equals to 11. Is that true? Does 0 equal 11? That is false. And therefore, this has no solution. Excuse me. So this is an example of a no solution because it says 0 equals 11. Whenever you have something like 0 equals 3 or 0 equals 4 or 0 equals a -17, that's false, and that means there's a no solution. Unlike the one we did previously, it said 0 equals 0, which is true. Therefore, we have infinite solutions. In this case, this is false. We have no solution. So this would be an example of parallel lines that we have looked at the past if we had to graph. The last method we're going to use is called the substitution method. And we use this example to show you how to do the substitution method. Now, all three of these methods, graphing, the addition method, and the substitution method, will all give you the same answer. But sometimes you may want to use one over the other because of how it's given to us. So let's look at this particular example in this system of equation. In this system of equation, we have 2x plus y is equal to 14. And then also we have 4x minus 2y is equal to a -5. In the substitution method, the steps are this. You want to rewrite one of the equations and then substitute into the other one. So let's show you what I mean by that. It doesn't matter which equation you're going to rewrite, the top or the bottom. You pick which one. In this case, I'm going to use the top one. And there's a reason why I'm using the top one. It's really because of this y by itself. Whenever I see a variable by itself, that's the one I'm going to use to rewrite. But you could have used the bottom one and still solve for the unknown. You solve for either x or solve for y. So let's use this one and show you what I mean by that. So solve for y for this. Now to solve for y, I will end up with y is equal to 14 and then move the 2x on the other side, minus 2x. So that's step one, rewrite one of the equations. So I decided to rewrite the top one. Y is equal to 4x minus 2y. You can solve for y or you can solve for x. It doesn't matter. Now this one you just rewrote, you're going to plug it into the other equation. That's your second step. So once I rewrite the top one, I'm going to plug it into the bottom one because y equals 14 minus 2x. Again, y equals 14 minus 2x. Therefore, I plug that into y into the second equation. And this is our steps of and that's why we call it substitution, because you rewrite one of them, and that rewrite, you plug it into the other equation. So in this case, when I write the 4x problem or equation, it'd be 4x minus 2y. Now, what is y equal to? Y is equal to 14 minus 2x is equal to a negative 5. And then we'll just solve for x. So 4x minus 28 plus 4x is equal to a negative 5. And then we'll just solve going across. So in this case, we end up with 8x is equal to, and I'm going to move the 28 on the other side. And so it becomes a positive 28. And so it'll be 28 minus 5 in our case. It'd be 28 so it'll be 28 minus the original problem. It really was a negative 12. 28, in that case, we move it over there. Minus 12. So it's not minus 5, it's minus 12. So notice the correction on the original problem. In this case, we'll end up with 16, and therefore x will have to equal to 2. Now again, since we have an x value, we also have to find the y value. So again, to find the y value, I'm going to plug this into my y equals to 14 minus 2x, and that would give me my y value. So 14 minus 2 times 2, and in that case, that gives me 14 minus 4, and that gives me 10. So y is equal to 10. So let's write that down. Now notice I'm going to circle this so you know where things are located at. This is an example of a one solution. X is equal to 2, y is equal to 10. And also, if you want to, you can write it. And I'm going to erase some of the work here so you can see another way to write it. You can write it as an ordered pair as 2, 10. And all you do is double check and make sure those numbers work for both equations. Plug in x, the value 2, and then for the value, or for y is the value of 10. And that works for both equations to double check it. Now let's look at another problem for using the substitution method. And let's say we're giving this. We're given 2x plus y is equal to 7, and 4x minus 2y is equal to a negative 6. So the first step, step 1, is decide which equation you want to rewrite in terms of x or y. In this case, I'm going to use the top one. I don't have to, but I'm going to use the top one and solve in terms of y. Y is equal to 7 minus 2x. So that's what y is equal to, 7 minus 2x. And so once you, excuse me, let me write that a little clear for you. I'm going to write it in blue so we can see that. So y is equal to 7 minus 2x. I'm going to substitute this equation into the second one. So the one you rewrite, you substitute to the other one. And in this case, when I substitute here, I'm going to show my work. I'm going to have 4x minus 2y. So what is y equal to? Y is equal to 7 minus 2x equals a negative 6. So this is my second equation and it has everything in terms of x. So now I can solve for it. So we have 4x minus, in this case, 14 plus 4x equals to a negative 6. You know, with 8x again, seemed like it. And then I'm going to move the 14 on the other side. So it'll be positive 14. That gives me a positive 8. And therefore, in our case, x is equal to 1. Now, I'm not done because I got to figure out y. So I plug in this x value, look, into this equation right here that I underline in orange, and it'll give me the y value. So 7 minus 2 is 5. So in this case, y is equal to 5. And if you want to write as an ordered pair, you can say 1, 5. And then double check to make sure this works in both of the top equations up here. So this is an example, again, of one solution or consistent. Now, if something happens when you use a substitution method and everything it gets canceled and you end up as a final answer is 0 equals 0, then we know that this means it's infinite many solutions. Let's say you use the substitution method and you say it gets me something like 0 equal to a negative 5. Is that true? Does 0 equals negative 5? No, it's false. So then my answer will be no solution. And you can circle that as no solution. So the substitution method, just like the elimination method or the addition method, basically falls under the same principles when it comes with the infinite solution and also no solution. Hopefully this helps in solving systems of equations. Basically, you want to focus on the elimination method and the substitution method because algebraically, you're able to see what the answer is and get an exact value. Now, remember, not all your answers are going to be integer values. In these examples, they were because I was showing you the process of how to use the elimination method or the substitution method. If you have other questions, feel free to use any resources that we have on our Mathlink website. And also, Make sure you review this particular video if you want to go over to understand some of the concepts that you possibly miss. Again, let Mathlink bring it together.